Today we are going to see the signal flow graph method. So this method again used to find out the transfer function of the given system. Again we have used block diagram reduction techniques to find the transfer function if the given physical system is complicated. Again, if the block diagram reduction technique also, if it is very complicated, the given system is very complicated, we cannot use whatever rules which is given to the system, means we cannot solve the block diagram by using a block diagram reduction technique. So again we have to go for further improved method to find out the transfer function. So here the further method to find out the transfer function of the given system is signal flow graph method if the system is so complicated. We are saying a signal flow graph method, we are using different definitions. Using these definitions only we are going to find out the transfer function of the given system. So here you are using a word node. A node is a point representing a variable or signal. So wherever you are having a variable, signals are changing, so in that particular point may be considered as a node. And next point is called as a transmittance. It is a gain between two nodes. So if you are having, for example, node 1 and node 2, so in between node 1 and node 2 you may be having a gain of G1. So that is called as a transmittance. And next notation is input node or source. An input node or source is a node having only outgoing branch. So from that input only outgoing signals will be there. So such type of node is called as an input node. And again you are having an output node or sink. An output node or sink is a node having only incoming branch. That is, from this output node you will not have any signal as output. Only it will observe all the inputs. So like a sink and source you are using in an electronic circuit. And again another notation is called as a branch. A branch is a line joining or connecting two nodes. So if you are connecting two nodes, through the branch only you can able to connect it. Either through the gain or without gain you can able to connect it. So the gain of the branch is called as a transmittance. So next notation is mixed node. A mixed node is a node with both incoming and outgoing branches. So here only in the mixed node you will be having incoming and outgoing branches. And next notation is loop. Loop is a closed path which originates from one node and terminates at the same node. That is, starting and ending of the loop is at the same node. That is called as a loop. And another term is called as a non-touching loop. It means the two loops are not touching. That is, should not have any common node. The definition is loops are not touching if they are not having any common path or branch. It is called as a non-touching loops. And next notation is path. A path is a transversal of connected branches in the direction of the branch arrows. So here with respect to control system and also that is especially signal flow graph and block diagram, the direction of arrow is very important. Only by seeing a direction we can able to identify whether it is in the forward path, the particular branch is in the forward path, or particular gain is in the forward path, or it is in the feedback path. So this arrow plays a vital role in case of a block diagram reduction technique and also in the signal flow graph. The next notation is forward path. A forward path is a path that starts from input node to output node, which does not cross self or any node more than once. So the traveling should be only once. It should not be more than that across the particular node is called as a forward path. Again, feedback path, a path that originates from a node and terminates at the same node. So starting and ending at the same node is called as a feedback path. Then feedback path gain is, a forward path gain is a product of branch transmittance of forward path. So this is your forward path gain. So next one. So these are whatever we have seen is a definitions. What are the different terms we are using? The definition for different terms we have seen. So using that notations only you are going to find out the overall transfer function of the given signal flow graph. So to find out the overall transfer function, in the previous case for block diagram reduction technique, we have used some rules to find out the overall transfer function or to simplify the blocks. But here you have to use a formula to find out the overall gain of the system. So the formula is named as a Mason's formula. So here this is nothing but the overall transfer function T is equal to 1 by del into summation, where K varies from 0 to kth value, Pk into delta K, where T is the overall gain of the system and Pk is path gain of kth forward path, and del is an 1 minus sum of all individual loop gains plus sum of gain product of all possible combination of two non-touching loops minus sum of gain products of all possible combination of three non-touching loops plus sum of gain product of all possible combination of four non-touching loops, and so on. So depending upon the complication of the given signal flow graph, this loop this delta value may be increasing or with less value. Okay, so you have to find out these values to find out the overall gain of the system. Here del K is nothing but del K is equal to 1 minus the loop which is not touching that particular forward path. So that is called as a del K. So using this different notations, you can able to find out the overall transfer function of the system. For example, we will take this signal flow graph. So here you can find out how many forward paths you are having. So first we will see what is a node. Here if you see, you are having an N1, N2, N3, N4, N5 up to you are having an N8, you are having n nodes. These are the number of nodes. So wherever you are having a chain, there you are marking a node. And here if you see G1, it is a forward path gain, and the input from the input to output, the direction of the arrow is marked. That is why I am saying it as a forward path gain. And again you are having an H1, it is a feedback path gain, since the direction of the arrow indicating that output to input. So like this you have to identify what are the forward path gains and what are the feedback path gains, and you have to identify what are the individual loops and how many individual loops are you are having, and whether you are having any non-touching loops are there. That is 2 possible combination of non-touching loops or 3 possible combination of non-touching loops. All those things you have to see. So this problem gives almost whatever the definition I have given. You are having a meaning of this diagram. That is, you are having an individual loops. That is, you are having G1 minus H1. Similarly G3 minus H3. Similarly G4 minus H4. And again G5 minus H5. And again G1, G2, G3 minus 1. So these are the individual loop gains you are having. And again you can see possible combination of 2 non-touching loops. We can consider G1 H1 and G3 H3 as 2 non-touching loop, because here you are not having any common nodes. the first loop, that is G1 H1, you are having nodes as N2 N3. If you see G3 H3 loop, you are having node as N4 G5. So in this case you are not having any common node, so you can say these two loops are non-touching. Okay, so you have to find out the product of these two, and then you have to add all the values in your del. And again, if you see the another possible combination of two non-touching loops are G3 H3 and G3 minus H5. This is also other possible combination. And one more possible combination, you can have G1 minus H1 and G5 minus H5. And again you can have three possible combination of non-touching loops also, that is G1 minus H1, G3 minus H3 and G5 minus H5. So like this you can find out the different possible combination. And again you can have two non-touching loop, one more thing, G1, G2, G3 minus 1 and G5 minus 5. This is also other possible combination of two non-touching loops. So like this you have to find out the loop gains, and then you have to find out product of two non-touching loops and product of three non-touching loops. All those things you have to find out. And again if you see the forward path, it is G1, G2, G3, G4, G5. Only one forward path you are having, and remaining all are the feedback path. So like this you have to find out individually how many forward paths you are having, what is a forward path gain, you have to find out. And again you have to find out individual loop gains, and again you have to find out product of two possible combination of non-touching loops, and again you have to find out product of three possible combination of non-touching loops. According to this problem you can able to find out, substitute in a Mason's formula, find out the overall transfer function of the system. So this is how you can able to find out the overall transfer function of the system. So here the signal flow graph itself is given. In some of the cases they will give you the block diagram. So from the block diagram you have to draw the signal flow graph, then you have to find out the transfer function. So this is how you have to find the transfer function in case of a signal. Thank you.